So in this video here, we're going to be continuing learning the unit circle. In the last video, we talked about quadrant 1 and how that's derived, and then we reflect it across the y-axis to get quadrant 2. So what we're going to do is fill out the entire unit circle and see how that's done, so how to get quadrant 3 and 4. But before I do that, let's draw our angles. So last time we looked at the unit circle, we made the angles using the right triangle. So I am going to draw my angles. So the first angle that sits on the x-axis, we always start at 0 degrees. So this is 0 degrees, and that is converted to 0 radians. And then afterwards, we learned that this angle here is 30 degrees, which is pi over 6. And after that is 45 degrees, which is pi over 4. And after that is 60 degrees, which is pi over 3. Write that a little bit nicer. Okay, and then we're going to learn the other angles here. So once we get to this tippy top here, this angle is 90 degrees. So at the very top, or the y-axis, this is 90 degrees at, I'm going to write it down here, 90 degrees at pi over 2. And then I'm going to draw my other angles. So then I just reflect across the y-axis. So this angle here represents the 60-degree angle. And then I'm going to draw my other angles, just to kind of fill in everything. So this flat line here on this side, the x-axis, is going to be our 180 degrees, or pi. To get these angles, what we did is we took the angles on this side here. So this piece here is a reflectant of the 30 degree. So we took 180 and subtracted 30 degrees, since this angle here must be 30 degrees if this side is 30 degrees. So if I subtract 180 from 30, I get 150. And if I take pi and I subtract it from pi over 6, we did this last time, that gives you 5 pi over 6. And then we continue to do it for the other angles. So for this angle here, I'm going to take 180, and this angle is a reflectant of 45, so this angle is 45 degrees. If I take 180, subtract 45, I get 135 degrees. And if I take pi and I subtract pi over 4, that is going to be 3 pi over 4. This guy here is a reflectant of the 60 degrees. So if I take 180 and subtract 60 degrees, that's going to give me 120 degrees, which is also equivalent to taking pi and subtracting pi over 3, which would give me 2 pi over 3. From there, I can find the coordinates, which we did using the right triangle properties. So starting down here, this first point, I want you to notice that the unit circle has a radius of 1. So if this radius goes out all the way to 1, that means the x value there is 1. But the y value is sitting on the x-axis, so that's 0. And then we mentioned last time, this one goes from the center outwards, so this point here is up 1 on the y-axis, so this is going to be 0, 1. The x value is 0 because it's sitting on the y-axis. So we're treating this as like a y-axis and an x-axis here. And then over here on the opposite end, you have to go in the negative x direction. So this is going to be negative 1, 0 for the y because it's sitting on the x-axis as well. Okay, so we're going to figure out the coordinate points here. So I'm just going to transfer what we learned last time. So from the last journal, we learned that 30 degrees is square root of 3 over 2 for the x and 1/2 for the y. That means that the 60 degrees is the opposite of this coordinate. So this one would be 1/2 square root of 3 over 2. And then pi over 4, or 45 degrees, is the easiest one to remember because they're both the same coordinates. It's the square root of 2 over 2. And that is the first quadrant. So this here is our first quadrant. Our second quadrant is going to be a reflectant of the first quadrant. So we mentioned last time the first quadrant has all positive numbers for the x's and y value, whereas the second quadrant has negative values for x and positive values for y. So that means what we're going to do is when we transfer over the coordinates, we need to make sure that all the x values are negative. Notice how that -1 here is on the second quadrant, whereas it is similar to the first quadrant 1, 0. But the 1 here is negative instead. So what I'm going to do is take the 60 degree, this coordinate, and paste it on this side. So this angle is identical to the 60 degrees. So I need to take the coordinates, which is 1/2 over the square root of 3 over 2. The only difference is I'm going to need a -1/2 because this x value is negative because it's in the second quadrant. And so this angle, the 45, is square root 2 over 2. So my 3 pi over 4 is going to be root 2 over 2, but my x value needs to be a negative. And last but not least, this guy here is equivalent to my 150 angle, is equivalent to the 30 degree angle, so I need to paste it on this side. So that's root 3 over 2, 1, and I need to put a negative square root of 3 over 2. All right, now that we have the first and second quadrant, let's go ahead and fill in the third and fourth. So for my third quadrant here, I'm going to need to remember that the third quadrant has all negative x and y values. So let's make a little note here. So my x and y values are all negative when you're in the third quadrant. So in the third quadrant, I'm going to draw our lines. So this one would kind of represent the angle that is similar to the 30 degree angle in the first quadrant. Notice that this is about 30 degrees from the x-axis. And then I'm going to draw like my 45 degree angle. So this here is about 45 degrees over. And then my last one here is my 60 degree angle. And so if I were to draw this piece, I want you to think about, this value right here. So if I know this is 180 and this here is about 30 degrees away from this line, that means I need to take, so let me do this on the side here. I need to take 180 degrees and add 30 degrees. And that will give me the angle that goes here. So that angle is going to be, let's see, 180 plus 30 is 210. So this is going to be 210 degrees. Now for this angle here, from this line to this line here, this angle is equivalent to 45 degrees. So if this is 45 degrees, I need to add 45 to that 180. If I do that, that is going to be 225. So this is 225 degrees. And then if I take 180 again and I add it to the 60 degrees, so this is about 60 degrees from the x-axis. If I add 180 to 60 degrees, I get 240 degrees. So this is 240. And so from here, also notice the pattern here. This goes from 10 to 25 to 40, which is about a pattern or adding by 15. And then here you guys might remember that this is your 270 degrees. Since this is 180, if you add 90 degrees, you get 270. Or you can consider this 3 pi over 2. So looking at this angle, I will fill in the radian side. So for the radians, I need to take pi and add about pi over 6 to it. So instead of using the degrees, I'm using the radian. So I'm taking pi, adding pi over 6. So let me erase this part here to make some room. So pi plus pi over 6, which is like my 30 degrees. Remember, I can put pi over 1 and then make the denominator the same as the denominator that I have on this side. So if I want to add these two fractions, the denominators both need to be 6. So I'm going to make this denominator 6 and the top a 6. So anything I multiply to the top, I got to multiply to the bottom. So 6 pi over 6. If I add the top, I get 6 pi plus 1 pi is 7 pi over 6. So this is 7 pi over 6. If I want to get this guy here, I have this piece equivalent to pi over 4. So I need to add pi over 4 to pi. So pi plus pi over 4. And so I have to change this denominator to 4 over 4, 4 pi over 4. So if I take 4 pi and add it with pi, I get 5 pi over 4. So this is 5 pi over 4. If I try to get this angle is equivalent to pi over 3. So if I take, let's make some room here. So if I take pi and add it to pi over 3, I need to find a common denominator. So this is going to be 3 pi over 3. If I add these, I get 4 pi over 3. So this is 4 pi over 3 as my radians angle. And then from here, I can figure out the coordinates. But before I do that, let's go ahead and find these angles since we're in that motion. So I'm going to make my angle. So this angle would be equivalent to my 30-degree angle. Notice the reflection. This would be about 30 degrees away from the x-axis. And that's about 30 degrees. So this one's about 30 degrees, this one's about 45, and this one's 60 degrees. So what I'm about to do next is figure out what is the angle here using the full revolution. So if I were to go all the way around the circle, we learned that a whole circle degree is 360 degrees, or 2 pi. So I'm going to use 360. And if I were to go backwards, right, from 360 to this angle, which is about 30 degrees, that means I have to subtract 30 degrees from 60. Well, 360 minus 30 degrees is 330. From there, I can grab the next angle. If I take 360 again, this is equivalent to 45. So if this is 45 degrees, take 360, subtract 45, that is 315. And then one more time, this angle here is equivalent to the 60-degree angle. So if I take 360, subtract 60, that's going to make 300 degrees. And all I have to do next is figure out the radians, which I'll be using 2 pi for. So I'm going to erase my work over here so I can make some room. So for radians, it's similar to what we just did. We're going to take the 2 pi and we're going to subtract about pi over 6 for the first angle. So this angle here is similar to pi over 6. So if I take 2 pi, I'll do it off here to the side. So if I take 2 pi and subtract pi over 6, well, then I have to change the denominator. So I'm going to put this denominator over 1 and find a common denominator. So if I want the top and bottom to, if the bottom to be both 6, I need to multiply the top and bottom by 6, which causes it to be 12 pi over 6 minus pi over 6, which is, well, 12 minus pi, 1 pi, is 11 pi over 6. So this angle right here is 11 pi over 6. If I want to find this angle here, again, I have to take my 2 pi, so this entire full circle, see if I can get my pointer out. So this entire full circle is 2 pi. If I want to go to this angle here, I need to subtract about 45 degrees, or pi over 4. So I'm going to take 2 pi and subtract pi over 4. So I'm going to put 2 pi over 1. And again, change the denominator. So I'm going to make the top and bottom multiplied by 4. So this is 8 pi over 4, minus pi over 4. So if I subtract the top, 8 pi minus 1 pi is 7 pi over 4. So that's 7 pi over 4. Okay, so now we're going to figure out the next angle. So let me make some more room here to do that. Okay. So the 30-degree angle is related to the 60 degrees. So it's related to pi over 3 for radians. So this distance from the x-axis to here, this angle is pi over 3. So I can take my 2 pi and subtract pi over 3 from it. So this is going to be 2 pi minus pi over 3. So I can make the denominator a 1 and multiply the top and bottom by 3. So this is going to be 6 pi over 3 minus 1 pi over 3. So that's going to be 5 pi over 3. So this here is 5 pi over 3. And now we have all the angles. So that did take us a while to do. But now being said, the coordinates here, they're going to be a lot easier to produce because they're just a reflection. Like, for instance, this side here is a positive 0, 1, right? Because it's technically in the positive region. Whereas this side here, notice it's going downwards for the y. So this is going to be a negative 1 instead. So right here should be 0, negative 1. It's 0 because it's sitting on the y-axis, so the x value is 0. But the y value must be negative 1 because it's in the negative region for y. So for these coordinates here, we're going to look at what the coordinates associate to. So this is 7 pi over 6, which relates to pi over 6. Notice the denominator, they're the same. So that means I need to grab this equation, this coordinate and pop it over here. So square root of 3 over 2 and 1/2. The only thing about being in the third quadrant is that both values need to be negative. So this is a negative square root of 3 over 2 and a negative 1/2. So I'm going to fill in the next one here. So this one, 5 pi over 4 is equivalent to pi over 4. So those are the root 2 over 2. But it's going to be a negative root 2 over 2 for both of them. Let me write that negative a little bit cleaner. There we go. And then the next one here is 4 pi over 6. It's related to pi over, I meant to say 4 pi over 3. It's related to pi over 3. So 1/2 comes first for the x value. So that's going to be negative 1/2 root 3 over 2, but it's going to be negative as well. And now I have those coordinates. And then this one here, same thing. This is 11 pi over 6, so this is going to connect with the pi over 6. So I'm going to grab that coordinate. So this is root 3 over 2 and 1/2. But this time, because we're in the fourth quadrant, you might have remembered. So the fourth quadrant, the x value is positive, but the y value down here is negative. So that means that the half here gets the negative sign. And then our next one here, 7 pi over 4 is connected to pi over 4. So I'm going to use that root 2 over 2. And the y value is a negative root 2 over 2. And last but not least, 5 pi over 3 is related to pi over 3. So that's this coordinate here. 1/2 comes first, and then square root of 3 over 2, where that root is a negative number. And that is the complete unit circle. So I know it was a lot to write down, but now that we have it, let's go over some of the trig values and ratios. So in this case here for cosine and sine, we talked about this before, but cosine is always your x value on a coordinate, and sine is always your y value. So if that's the case, so sine is your y value and cosine is your x value, tangent is going to be y over x. And the reason why this is the case, and I'll kind of try to show you guys, if we think about a right triangle just anywhere, Like I'll pick this spot right here. We just look at our right triangle. You don't have to draw this part on your sheet of paper. If I think my angle here is 30 degrees, right? Because this here says 30 degrees, then tangent is always the opposite over adjacent. So tangent is always opposite over adjacent. Well, the opposite here is the y value, whereas the x value here is the adjacent value. So the adjacent part is actually the x value on this coordinate system. So that's how we come about of y over x. From there, we can figure out all the rest of the pieces. Like for instance, the cosecant. Cosecant is going to be the reciprocal of sine. And so if we think about sine for a moment, technically this is y over 1, right? Because the hypotenuse was 1. This hypotenuse right here for the right triangle is always 1. So in that case, this cosecant is the reciprocal of sine. So this is going to be 1 over y. Now I'm going to erase this part here just because this looks really weird to me to have like y over 1. There we go. And then for cosine, we can think of that as like x over 1. So the secant is the reciprocal of that. So that would be 1 over x. And then cotangent is the reciprocal of tangent. So that's going to be x over y. And that's all the trig values here. In the next video, I'll have you guys watch a tutorial on how you can use this hand trick to figure out the first quadrant of the unit circle. Because when we really think about it, if you know the first quadrant, you can figure out all the other quadrants. As you can see that what I've done in the past few days, once I derived the first quadrant, I knew how to reflect and add and subtract to 180 degrees or 2 pi in order to get all the other angles and all the other coordinates. But that's it for this video. I hope you guys found this helpful. Email me if you have any questions. Bye guys.